This is part 2 of my series on designing a simple firewood drying shed. In episode 1, I emptied the shed and moved the wood closer to our house and restacked it into our larger timber frame style woodshed. And with the smaller shed emptied, I was able to take measurements and come up with a rough sketch on paper. Then take those diagrams and measurements and create a 3D CAD model. If you haven't seen part 1, then maybe you'll get more out of this video if you watch that first. In this episode, I'll take that 3D model and create a fully dimensioned drawing from it, with all the views and details required to build it from standard nominal framing lumber. I'll also make an automatic cut list from a Sketchup plugin. Finally, I'll use another plugin to create an animated sequence showing the shed being assembled. And finally, I'll show you how I add sound effects for the animation using Final Cut Pro, the video editing software I use. I'll start in SketchUp with the completed model. I'll need to create all the standard and detailed views before I can begin to add the dimensions. And I'll also have to determine what I want to have visible in each of the views. And this is mainly controlled by the layers, or tags, that are visible or invisible. When building the model, I tried to group objects and components into layers of similarity. I'll create some of the overall standard views like top, front, right, left, etc. And there's icons for selecting these standard views at the top of the screen. Then I'll change the camera view from perspective to orthographic. Then turn off the shadows. Then create a new scene with the plus sign. Scenes in the model will become views in the drawing. I can rename this scene to something that's more descriptive than just Scene 4. I'll call it Front. My orientation of the model when I built it was off by 90 degrees, so I'll just have to keep that in mind when I'm working here. Clicking the front icon gives my model a right side view, and that's no problem as long as I stick with the current naming convention I'm using. I'll make a few more scenes and rename them. For this top view, I'll deselect some of the visible layers to show just the floor and joists for this particular view, and I'll call this top-floor. I'll go back to my left view and deselect some layers from that one, then create a view and call it left-walls. And I can do the same for my first top view. Deselect some layers and create a new scene and call it top-joists. From the back of the shed, I'll make some views of the floor and wall braces. With those views done, I have enough to start the drawing. I'll now send that model from SketchUp to Layout, the program for assembling views and adding dimensions and detailed notes, etc. Layout asks me to select a drawing size and scale and/or a template. I'll select my custom Man About Tools template I use for most of my drawings. Then I can set the drawing name and other details for this project. It automatically added the view of the corner brace. I can change that to the scene or view I created called Cover, and this is the image I want on the cover page of the drawing. And I can roughly position and scale that view. I'll rename the second page to Front View, then copy and paste the view from the cover page to page 2. Then adjust the scale so it will fit the page. Then I'll add a few overall dimensions. Then set them to imperial, feet, and inches. Later, I'll add metric equivalents to each dimension. Unfortunately, there's no automatic dual dimensioning feature in SketchUp. I'll add another page and rename it. Copy and paste a view onto this page, then select what scene I want. I can resize the bounding box and reposition the view. Then copy this over and select a different scene. This is also the left side, but only shows the joists and walls. I can change my dimension style from architectural to engineering to decimal or fractional. There's a lot of flexibility here. I'll add an angular dimension for the slope at the top of the wall. And I can adjust the precision of the dimensions. I like to get as many rough dimensions added, then fine-tune their positions as I go along. Inevitably, lines and numbers will run into other dimensions, so there's a fair amount of adjustments you need to make before the final drawing is done. Here I'll copy that wall view and move it up. Then change its scale to make a detailed enlargement. I'll need to change its bounding box to get it right where I want it. I can add some dimensions for the notch at the top of the wall that needs to be cut, the flat face of 5.5 inches, and also the distance down from the peak of 5 5/8. I'll also add dimensions for the spacing between the wallboards. I'll add another page and name it braces. Copy an existing view onto this page and change the scene and scale. So I have a front view of the floor and upper wall brace. And I can add some dimensions to these. And that's the basics of making a drawing. All those steps get repeated over and over until all the key information is there in one document. It might just be me, but I see it as creating a piece of functional artwork. I've always appreciated elegant drawings that pack a lot of detail into a small space without it feeling crowded, or some elements encroaching on others and diminishing their readability. It's satisfying when you can pull that off. Here's a page from my bench drawing that I think illustrates those goals for me. This is a plugin for Sketchup called Open Cutlist. With the model in the view and all the relative layers visible, I can hit Parts, then Regenerate, and presto, there's a cut list. That is very cool. I can click the Draw button in the Parts List summary, assign some of the variables, or just use the defaults, and hit Generate. It will show a fully labeled view of your project that you can rotate and also expand to create an exploded view. I've only just started to play around with this plugin, and it is detailed and impressive. You need to assign and define the material of the components, and in SketchUp that's very easy. I do that in the Materials palette where I can define the color of an item, and I'll talk a bit more about that in a second. Back on the Summary page, it lists all the board sizes I can buy and the total quantities required. And if you assign a price per foot for each of the materials, then it will also generate a material cost for you. At the time I was working on this, it would cost approximately $400 in lumber. On the Materials tab, I can define the board's standard lengths, plus any oversized variables. For example, a 10-foot board is actually an 1/8 or 1/4 inch longer when you buy it. In this window, I have a 10-foot board and listed all the standard nominal sizes, such as 1x2, 2x4, 2x6, 2x8, and 1x6. And you can add more if you need. I entered the actual sizes here. And I set this as dimensional under material type. Prices are set under the Attributes tab. I did do a bit of work trying to initially group components into what I thought was the most efficient board length, but I think the plugin can do all of that for you. So back on the parts list, It shows the part name that I defined for the component, a part letter, A, B, and C, the quantity of each required, plus a rough and finished length. And you can generate a drawing that will show only those components that are made from that particular board length and size. If you hit the cutting diagram button, it will provide a visual reference for all the rough cuts you need to make. For the fascia, part E for example, you can also double-click it and it will highlight that part in the model. Also, very cool. Let's pick another one. How about part M, the short base 2x6? A single click on the part name shows that part. And it will indicate the number of boards dedicated to each of the rough cuts. You can also export a CSV file, comma separated like a spreadsheet. And I'm sure there's more that this plugin can do if you dive into it further. When I shoot a video for a project, I try to have at least one shot on a 30-degree or so angle, showing the entire structure. I do this so I can create a fade-in from a live shot and into the equivalent 3D model. Here is a scene from part 1 where I'm taking measurements of the empty firewood drying shed. It's a short static shot with the wind blowing the trees. It's a bit too short for my liking, but I can add a freeze frame, the blue clip, and do a fade or cross dissolve into it, and thus make it longer. Next, I go to a shot of me at my kitchen island working on the model. Between those two is where I want to drop in the animated sequence. I'll export a still frame of that scene to a JPEG file. And I'll put that in a folder where I have my SketchUp model. And here's that image. Now I'll get out a Final Cut and go into SketchUp. I have the origin of my model axis set to the front corner of the model, at the top of the concrete block. I'll select Match New Photo from the camera dropdown and select that image. I'll first position the model axis to the corresponding point of the photo. Then scale the model up along the blue or vertical axis. What I want to do here is slowly edge the model to match the photo. On the left side of the axis, there's two green dashed lines. I will try to align them with parallel lines in the image. To the right of the blue axis, there's two dashed red lines. I will try to line those up with parallel lines on the image on the right side. It won't work off the edge of the sloped roof, so I'll try the wall crossmember. And the other one on the edge of a floor 2x6. It takes some adjusting and readjusting to line everything up. Also, my model is a bit different than the shed I built. It's similar, so I should be able to pull off a pretty close match. Okay, I like that. Then, in the Styles tab, I can turn off the matched image. I created a large rectangle to act as the ground and adjusted the shadow date and time of day so it would land on this rectangle. So I have two scenes here, the one that matches the photo. The second scene will show the components dropping in from the sky to assemble the model. To generate the animated sequence, I'll be using a SketchUp plugin called Animate from Fredo 6. To start with, I need to freeze, or record or save, everything as it is using the positioner. As I'll be moving pieces around, they can be challenging to get back to their starting positions. Next, I'll create a new film and give it a name, and I'll call it Shed 1, and select Positioner 3. I love and hate this plugin. I love the results it can generate and all the features it has. I hate how clunky it is to use. It is nothing short of tedious to work with. But hey, the price is right and it does work. First, I'll add a camera or scene to the timeline. The timeline will hold all the camera positions and all the moves that each of the components will be making. And this is also a representation of the length of time for each move. In the timeline, there's a green bar for the first camera position, and it is the scene position 1. I can then set how the camera is going to move from one scene to the next. It defaults to a linear motion, but I want it to smoothly ease in and ease out. I'll add some more time to the overall sequence. Then at 4 seconds down the timeline, I'll add another camera green bar at position 2, the slightly zoomed out view, and also change the ease in and out to be smooth. Fredo 6 has a whole collection of other very excellent plugins for SketchUp. The dude is truly talented. Now I can hit the play button to preview that animation. Now I'll enter a unit of movement in the timeline, then select what I want to be moved. I'll pick the roof sheet metal component. Then select the Translate button, pick the vertical axis, pick a reference point anywhere on the model, then drag the roof skyward. I'll then key in 20 feet as the distance. I'll save that sequence and you can see the blue bar added to the timeline at 5 seconds. And the length of that move is 2 seconds. Next, I'll adjust the easing so the roof starts off gradually and quickly comes to a stop 20 feet up. Oops, I selected the opposite type of easing, so I'll fix that. I noticed that the shadow of the roof 20 feet up was still visible. So I'll exit out of Animator and change my shadow settings, and deselect On Ground. Now when I go back into Animator, the shadow disappears from the ground and only falls on the rectangle. So one of the key concepts to showing a model being assembled is to create that animation in reverse. Animate it being pulled apart as I've started here, then play that back in reverse so it looks like it's coming together. I find that to be the easiest way to do this. Okay, so let's add another unit of movement in the timeline. And select a roof slat. Then select the Translate button and click the blue vertical axis. Then click a reference point anywhere on the model and drag that skyward. When I release the mouse button, I can key in 20 feet. And that will take place over 1.5 seconds. And click to save that sequence. And I have to remember to set the type of easing I need. When I select that bar, it brings up a detailed box showing attributes for that unit of movement. And on the model, it shows the outline of the slat in red and a line going skyward. To keep the timeline more organized, because it's soon to get busy and crowded, I like to change the color of the bars. I can select a red color from the panel and it adds a swatch to that color on the blue bar. And having these units of movement overlapping is also important. I mean that the roof metal is still in motion when the first roof slat takes off. Now I'll right-click and copy that bar and paste it at 6.5 seconds. To use this unit of measurement on the second roof slat, I need to click the number 1 in the panel to make it unique, and not connected to the first slat. Then I double-click the bar and hit the X selection box to disassociate the first slat from the movement. That allows me to pick a new part of the model to move skyward by 20 feet. So I'll select the second roof slat. Hang in there, it's going to become more clear as I go along. Now I'll play the animation and you can see the second slat following the first skyward. And I can continue this copy and paste method and reassigning the same movement to a new roof slat. And I'll leave the same red swatch on these 5 movements as they're all related. And if I play the animation backward, the roof is being assembled. So far, everything has gone in a straight line upwards and has slowly accelerated and ended quickly, which is outside the view. Next, I'll animate the front fascia board. I'll select New Movement, pick the board, and then I'll select the X-axis as I first want it to move forward. I'll drag it forward, release the mouse button, then key in 6 inches. And I want that move to occur over a half second. And I'll make the swatch on the bar a light color. And select an easing that slowly accelerates and slowly decelerates when it ends. Now I'll add another movement to that same fascia board that starts halfway through the first move, but goes vertical by 20 feet over 1.5 seconds. So the effect when I play the animation is it looks like the board curves away from the shed before it goes skyward. This is what an overlap of these 2 moves creates. For a quarter second or so, the board is moving both toward the viewer as well as upwards. So I can then copy that first move in the X direction and apply it to the fascia board on the back of the shed, and change the direction to -6 inches. And I can copy and paste the move upwards, make it unique, then apply that to the rear fascia board as well. Now both fascia boards move at the same time. I can select several movements in the timeline and drag them to change their start times, or paste copies of several selections as well. I'll make all 4 of those copies unique and with a different color. And then I can apply each move to a different board. Here I'll apply them to the fascia boards on the right and left side of the shed. And those side fascias will first move in the Y direction. So this is what we have so far. So those are the basic steps I use to create this animation. It takes a while, and staying organized with color coding the movements really helps. The timeline automatically expands to fit more and more movements, and you can zoom the timeline in to focus on just one area, and that helps a lot too. And I save my work quite often, every few minutes or after I've created a few sequences. So it's basically the same steps over and over again. Copying and pasting selections works well, and you can also move a few items at a time. Not every component needs to be moved on its own. The deck boards I had dropping in 2 at a time, and that's less work than creating a movement for each. When I'm happy with how that looks, I can then generate or render the animation into a movie file. I select MP4 with a frame rate of 60 per second, even though my timeline in Final Cut Pro is 24 frames per second. Final Cut will take a 60 frame per second clip and convert it to 24 and add some motion blur. I think it gives me a much smoother animation in the end, even though it takes longer to render. I also set the render dimensions to a 4K size image. And away it goes rendering. On my Mac Studio computer, this 28-second sequence will take around a half hour to complete. When done, I can add that clip to the episode I'm editing in Final Cut. Here's the two clips when I was taking measurements for my sketch, a medium shot followed by a wide shot of the entire shed. Next, I have a long fade into a freeze frame of the model in the same position, and another fade into the animation that starts with an empty rectangle. At the end, it fades back into the real shed before fading briefly to black and to me sitting down at my laptop. Below the animation clip are all the sound effects I added to bring it all to life, so to speak. Below that, the green bars are ambient sounds and effects. I have sounds of a farm field, plus 2 additional sound effects that I hope add to the fade from reality to the model. And those effects play again at the end of the animation. Here's how it looks and sounds without my voiceover description. Lots of swooshes, bumps, thuds, and clicks, and a clang at the end for the metal roof. Now I'll turn my voiceover back on and play it through with a description. The shed sits on 6 concrete blocks, or can be secured to poured footings with post saddles. Over the blocks are floor joists, topped with deck boards. There's 2 outside walls and a middle dividing wall creating 2 firewood storage bays. Then 2 floor braces around the back and 4 rafters with blocking. Connecting the walls and rafters are 4 1x6s and front corner braces. Fascia boards complete the overhangs, and the shed is topped with strapping boards and a metal roof. I think the subtle background sound effects improve the animation greatly. There's a lot of them to add, and it takes a while, but in the end, I think it's worth the effort. And with YouTube, you can't change, improve, or fix anything after it's posted, so I try to get it the best I can before that. So I think that covers everything I wanted to talk about in this episode. I hope you enjoyed it. Thanks very much for watching. If you have any comments or questions, just post them below. We'll see you next time.